So today's lesson is about the chain rule for partial derivatives. As you know, in Calculus 1, you have studied the chain rule in details. And even in the some of the examples that we did in one of the last week's lesson, we used that version of Calculus 1 of chain rule to compute partial derivatives. But today we talk about another aspect of the chain rule with regard to partial derivatives. So let me first give an example before talking more in depth about how the chain rule or this version of the chain rule comes into play in partial derivatives. So in this example, we have a function z. So z is a function of two variables. Suppose the two variables are x and y, and z is defined as x times e to the power of y. So this is the main function that we have. And here, x and y themselves depend on another variable t. So x is a function of t. In this example, it is t squared. And y is another function of t. In this example, it is 5t. So when we look at this, z is a function of x and y. And x and y on their own are functions of t. So at one level, z is a function at x and y. But since x and y themselves are functions of a single variable t, I can imagine that z at the same time is a function of t. So the question here is, what is the derivative of z with respect to t? Here, I don't need to use the notation for the partial derivative because at this level, z is a function of t. At the level of t, t is the only variable. Later in this lesson, we see that the cases that in addition to t, we might have some other variable s at that level. So the question is find this. So before we do this example, let me explain in general how we deal with this and then come back and finish this example. Tree diagram. So we use a tree diagram to explain this. Again, z is a function of x and y. X and y are, with respect to z, are two independent variables. But x and y are dependent on a single variable t. So this version of the chain rule says that if I want to find dz over dt, the derivative of z with respect to t, I should find two chains of the derivatives. One chain is here, and one chain is here. So for z to get to t, it goes through x and through y. Through x is partial derivative of z with respect to x. Then to get to t times the derivative of x with respect to t. Since x depends only on t, not another variable, that's why I use the regular or calculus 1 notation of dx over dt. But at this level, partial derivative of z with respect to x, I needed to use the other more recent notation, because at the level of x, we also have y. So this is for this branch of, or this chain of functions that I get to t, then plus, I should add it up to the other chain. Partial derivative of z with respect to y times dy over dt. So this is one chain rule regarding these kinds of problems, that z is a function of x and y on their own are functions of a single variable t. So to find the derivative of z with respect to t, I should find partial derivative of z with respect to x, then multiplied by the derivative of x and then add it up to partial derivative of z with respect to y and multiplied by the derivative of y with respect to t. For the derivative of y with respect to t, it's not partial because y is a function of a single variable. So let me go to the previous slide and apply these to this example. I would suggest that you pause the video and try to do this on your own before watching my solution. So based on what I said, to find dz over dt, I should find partial derivative of z with respect to x, then multiply it by the derivative of x with respect to t, add this product to another product, and the other product is partial derivative of z with respect to y times the derivative of y with respect to t. So this dz over dt is equal to the sum of these two products. Okay, now let's find all of these components and do the calculation. Our final answer must be in terms of only t. So we should be careful that the final answer that I will write or type inside that box must be only in terms of t. But for now, we do this calculation, partial derivative of z with respect to x. With respect to x means that I assume that y is a constant. So e to the y is a constant. E to the y times x, the derivative with respect to x is just e to the y. So this is e to the y times the derivative of x with respect to t. X is t squared. The derivative with respect to t is 2t. Partial of z with respect to y. Again, in z equals x times e to the y, I assume x is a constant and y is the variable. Partial derivative is constant times the derivative of e to the y, which is e to the y with respect to y. So again, it is x e to the y, because I deal with x as a constant and y as the variable. And times the derivative of y with respect to t, the derivative of 5t is 5. So first of all, I write this in the standard form, 2t e to the y plus 5x e to the y. As I mentioned, I should write everything in terms of t. So from the beginning, so 2t e to the power of, instead of y, I used 5t. So replace y by the equal term of 5t plus 5x. Replace x by t squared because x equals t squared in this example. Times e to the power of y is 5t, so 5t. So that's the final answer that I need to post inside, right inside this box. 2t e to the power of 5t plus 5t squared e to the power of 5t. I cannot combine these two terms because in the first term it is t and the other one t squared, so I cannot combine them. And you don't need to factor anything here. Of course, if we were able to combine them, we had to combine. But factoring, no, there is no need to factor anything here. So that's the final answer for this example. Okay, let's do another example. Let z be a function of x and y defined this way. Sine of 2x times cosine of 3y. So z is this product, sine of 2x, cosine of 3y. Besides, x on its own is a function of t, x is 3t, and y is t squared. Again, here I see that z is a function of x and y at this level. But when I go further down, I see that x is a function of t and y is a function of t. So it tells me that I can think of z as a function of t. Now the question is to find dz over dt. As I mentioned in the answer, I should write everything in terms of the lowest variable, in this case, t. Okay, so I need the chain rule here. Again, please pause and try to do the example on your own, and then compare your answer with my answer. So using, so we should use the chain rule. Using the chain rule, this is gonna be the derivative, the partial derivative of z with respect to x times the derivative of x with respect to t plus partial derivative of z with respect to y times dy over dt. So that dz over dt is the sum of these two products according to the chain rule. So what is partial derivative of z with respect to x? Look at the top, z is sine of 2x, cosine of 3y. So I should look at cosine of 3y as a constant And sine of 2x, its derivative with respect to x using the calculus 1 chain rule. The derivative of sine of 2x is 2 cosine of 2x. So what I have here for this is 2 cosine of 2x times cosine of 3y. Again, the reason is I look at y as a constant, therefore cosine of 3y is a constant, and the derivative of sine of 2x is 2 cosine of 2x. So this was the first partial derivative, then times the derivative of x with respect to t. X is 3t, so times 3. Then plus partial derivative of z with respect to y. Again, in the function z equals sine of 2x times cosine of 3y, I should look at x as a constant. So sine of 2x is a constant, and the derivative of cosine of 3y with respect to y, that kind of chain rule that you learned in calculus 1, the derivative of cosine of 3y with respect to y is minus 3 sine of 3y. So I will have sine of 2x is just like a constant. The derivative of cosine of 3y with respect to y is minus 3 sine of 3y. Here it was sine of 2x, sorry. So this was the partial derivative of z with respect to y. What about the derivative of y with respect to t? Y is t squared, so the derivative is 2t. Now let's simplify this a little bit. And as I mentioned before, at the end, I should write everything in terms of t. So in the first product, 3 times 2, 6. Cosine of 2x cosine 3y. Over here, the next term, minus 3 times 2t is minus 6t. That comes first. Minus 6t. Sine of 2x. Sine of 3y. And now I write everything in terms of t. So 6 cosine of 2x. X is 3t. 2 times 3t is 6t. Cosine of 6t. Cosine of 3y. Y is t squared. 3t squared. Minus 6t sine of 2x. X is 3t, so it's going to be 6t. Sine of 3y, y is t squared, so 3t squared. So that's the answer that should be typed inside this box. 6 cosine of 6t cosine of 3t squared minus 6t sine of 6t sine of 3t squared.